move on to the next example. So in the next example, if we wanted to calculate the generators of the subgroup of order 9, so here the group that is given is Z36. So this group is given to us, so that means n is equal to 36 here. So they are asking calculate all the generators of the subgroup of order 9. So here we are given k as equal to 9, which is the order, right? So from this we may calculate the subgroup. It is calculated in case of Zn. We calculated by doing this n divided by k. So it is equal to 4. So that means 4 is one of the generators, and hence we have the subgroup generated by 4 as one of the subgroup of Z36, right? And it would have order 9, right? So what all elements would be there in this? It would have 0, it would have 4, it would have 8, then it would have 12, then 16, then 20, 24, 28, right, 32, and the last element would be 36, which is essentially 0. So no need to write this one because we have already mentioned 0 here. So in total we have 1, 2, 3, 4, 5, 6, 7, 8 and 9 elements with us. So these are the elements of the subgroup which is generated by 4. It has order 9. Moreover, we want to list all the generators for this. So other generators, they are obtained by using the previous result. Remember, we have studied this result about the generators of Zn in a finite cyclic group. So the generators, they are obtained for an integer k in Zn. We have it as a generator of Zn if and only if the GCD of n with k is equal to 1. So now you have n as equal to 36, right? Not 36, because we wanted in this case n k is given to be 9, right? The order is given to be 9. So we wanted to calculate all those numbers such that the GCD is equal to 1, correct? So let's see the result here. So here the other generators of Z36, they are of this form 4 multiplied with j. And how do you calculate j? You calculate j by taking the GCD of 9 with j as equal to 1. This should come out to be 1. So when this thing should be equal to 1, so that means you are looking for those number j such that they are relatively prime to 9. So what all numbers would be there of such kind? So it would be 1, it would be 2, it would be 4, it would be 5, 7 and 8. Why? Because all of them, they have GCD equal to 1 with 9, right? If that is so, so that means we would have 4 multiplied by 1 as one of the subgroup. Another subgroup would be 4 multiplied by 2, because the subgroups, they are of this form 4 multiplied with j. And what is j? J is obtained like this, the multiplication of 9 with j. Actually it is GCD of 36 with 4j, or you can write it to be I, right? So let me write it I. So we can take 4 common. So if I is equal to 4j, suppose, so we have GCD as so it could be written as 4 into 9 and it could be written as 4 into j, right? And next we can write this to be GCD of 9 with j. So this thing should be equal to 1. So that means we would have the subgroup generated by 4 multiplied by 1 equal to subgroup generated by 4 multiplied with 2. Next is 4 multiplied with 4, 4 multiplied with 5, 4 multiplied with 7, all these numbers, 4 multiplied with all these numbers, and equal to 4 multiplied with 8. So we have one of the generator as 4, another generator is 8, another is 16, another is 20, another is 28 and another is 32. So these are all the generators here, and all these subgroups, they are equal to each other, right? So in general, if we wanted to calculate all the subgroups of the group which is generated by A having order as 9, where the order of the element itself is 36, so in that case, now we were talking about the group where we have the group as Z36. Now in this case, if we wanted to calculate the general cyclic group, not the addition modulo group, right, integers modulo group, in that case we would have a to the power 4 raised to power 1 as, because with 9 you see which number have GCD equal to 1. So we saw J is equal to 1, it was equal to 2, not 3 but 4, 5, not 6 because they have 3 in common, then 7 and 8, right? So that means a raised to power 4. We already knew that 36 which was n divided by d which was 9, so this is equal to 4. So a raised to power 4 is one of the generator. So other generators are obtained when you take the power as 1, this one j. Another one is a raised to power a raised to power 4 raised to power 2, a raised to power 4 raised to power 4, a raised to power 4 raised to power 5, a raised to power 4 raised to power 7, a raised to power 4 raised to power 8, and so on, right? So that means the subgroups which are generated by all these generators, they are equal to each other. And in general we have this result that whenever we have the generator a raised to power n divided by d, right? In our case we had n was 36, d was 9, so we have the generator as a raised to power 4, right? The subgroup of order d, so this is the subgroup of the group this one having order. So in our case the order was 9, right? Because the value of d was 9, where d was the divisor of this order 36 in our case. All the generators of this have the form this. So that means we have this, so we have a raised to power 4 as one of the subgroup, right? So all the generators of this subgroup, they are of this form that we have this a raised to power 4 raised to power j, where what is this j? J is the number which is relatively prime to d. So this is same as writing j belongs to ud, and this is same as writing the GCD of j with d is equal to 1, right? So this is what we have covered here. So I hope you understood this result. Well, that is it for this video. Thank you for watching.